So we're now going to talk about another implementation for the PrimeCheck app case study. This particular implementation is going to use features related to the Java Completable Futures framework. We're not going to spend a lot of time talking about that in this class. That's something we covered in my other class. But I do want you to sort of see another way of doing things just to compare and contrast how to implement different concurrency models. So this particular implementation is going to be part of the EX1 project in my WebMVC folder in my Live Lessons GitHub repository. And here we are in that repository. Let's go ahead and open up the Completable Future strategy. You can see that this implements the abstract strategy superclass, which defines that one method, the checkIfPrime. There's no real concurrency possible there because it's doing just one thing. But when we take a look here in the checkIfPrime method list, checkIfPrimeList method, you can see something more interesting. So remember, this takes in the list of prime candidates and a Boolean parameter. And we use our good old try with resources block up here. And you can see it's going to start out by either making an executor that's the ForkJoin common pool or a single-threaded executor if we just want to run it in a single-threaded mode. We then convert the list of prime candidates into a stream. We call the map method. And now we're going to do something quite interesting. We're going to use the Completable Future factory method that makes an asynchronous task. So what this is going to do is it's going to run the isPrimeCheck on whichever executor we have selected here, which is either going to be the common ForkJoin pool if we're doing it in parallel, or a single-threaded executor. In any case, what's going to happen is that this piece of code, this so-called action, which is really a Lambda expression, is going to be scheduled for execution to run concurrently in the background. And so for each of these different integers, we're going to schedule a separate operation to run in the background. Now what we're going to do then is we're going to use the collect mechanism, which, if you recall, collect is a terminal operation in Java streams. And we're going to collect everything into a single future using this thing called the FuturesCollector. So let's go take a quick look at that. Here's the FuturesCollector. As you can see, it's got a factory method that makes a new instance of the FuturesCollector. What is the FuturesCollector? FuturesCollector is a collector that's going to take a stream of completable futures to some type T, some generic parameter, in this case, going to be integer. And then it's going to return a list of completable futures to type T. Sorry, it's going to use an accumulator that's going to accumulate this into a list. We'll see how that works in a second. And then the final parameter here, it's going to return a completable future to a list of T. And when that completable future triggers, that means that all the operations have finished running asynchronously. So here's the supplier factor method that makes a new array list. That's what's called the mutable result container that stores all these results. We simply add each new element in the stream to this list internally. The combiner doesn't get used. Let's ignore that. Here's the thing that really does something interesting. This is the finisher method. And when this method is called, that means that the operations have all been collected into the stream, and now we have to complete them. So what we do is we take the list of completable futures, which we stashed away in the mutable result container, and we convert that into an array of completable futures, and we use the arbitrary arity method all of, which is a super cool completable futures feature that's going to return a single completable future that will trigger when all the asynchronous operations are finished. And when that happens, then we go ahead and take the list of completable futures. We map each element using completable future join, which converts a completable future to a type, completable future to type T to a type T. So we end up with a stream of objects of type T. And this will always succeed because we don't get to this point unless all the operations have finished running in the background. And the final thing we do is we turn that stream of objects of type T into a list of objects of type T. And then that comes back as a completable future. And so what we get here out of collect is a single completable future that, when complete, will have produced essentially a list of results. And then we go ahead and block until all the asynchronous processing is done. So this is a very, very cool mechanism for using completable future. I think it's a little bit more complicated than using Java parallel streams, but it's, at least for my money, not as syntactically dense as using the structured concurrency mechanism, although you do have to understand a little bit about things like futures collectors and asynchronous processing and so on. So that's one implementation. Then just for kicks, here's a second implementation that uses completable future. And the only difference here is that this implementation is going to end up using a virtual thread per task executor as opposed to the common ForkJoin pool. So what that means is that every time we call supply async down here in this stream, it's actually going to create a virtual thread to do the computation. So this is just really demonstrating that it's possible to take a mechanism like Java virtual threads, couple it with Java completable futures, and be able to have each asynchronous operation run in its own virtual thread, which is a really cool combination of two paradigms. Most people don't really know you can do this. There's more sophisticated ways of doing this, but this one works for our purposes here. So that's the second half of the implementation strategies I wanted to talk about. Just to quickly recap, if we take a look back here, this is what parallel streams look like. I think you'll agree that it really is very, very short and sweet. All you do is convert the list of integers into either a stream or a parallel stream of integers, run them all in parallel if you're doing the parallel stream version, and collect them into the list. So that's really, really concise. Arguably, well, definitely more concise than the asynchronous version, although not that much different. And certainly, at least for my money, more concise than doing the implementation using the mechanisms that are provided with the Java executor service that uses the virtual thread pool. Although I guess arguably this is pretty simple too. The main difference that we have to deal with here is we had to convert the results back from a list of futures to a list. So that's a little bit more work. We'll take a look at some other things. Remember, this is just an example that uses the executor service variant of the structured concurrency. We'll see more fulsome structured concurrency mechanisms in other examples.